Welcome to the Voxler demonstration video part 3. In this part, I will demonstrate how to create an isosurface and change the properties of various modules. To start, I'm going to demonstrate how to convert a scattered data set into a three-dimensional object. The gritter module converts the scattered data into an array of data known as a lattice, which can then be used to create an isosurface or other 3D graphical output. To start, go to File and New to start with a new project. Then go to File and Load Data. Navigate to the Voxler data folder and select xyzc1.dat and click Open. Two Data Import Options dialog boxes will open. Click OK on both of them to use the default settings and to import the data. Now I will add the gritter module. To do this, select xyzc1.dat in the network window and double-click on gritter under the computational folder in the module library window. Select the gritter module in the network window. Notice the indicator LED on the gritter glows yellow until the gritting process is complete. When complete, the indicator LED will switch to glowing green. Now look at the Properties window. You can change the gritter properties in this window, such as grid geometry, gridding method, and search type. When the settings are what you want, click Begin Gridding. A process dialog box will show the process of the gridding calculation. For this demonstration, the default settings will be fine, so click on Begin Gridding. Now that the gridding is complete, the isosurface can be added. An isosurface is a three-dimensional surface of constant value that quickly reconstructs a shape from the data. With the gritter module selected in the network window, double-click on the isosurface module in the module library window. The isosurface module will appear in the network window, and the isosurface should now be viewable in the viewer window. I will now demonstrate how to create an isosurface that doesn't require the gritter module. To get started, go to File and New. When prompted to save changes, click No. Now go to File and Load Data once again. This time, select ct_foot.vdat and click Open. Now the isosurface module can be added by selecting the ct_foot.vdat module and double-clicking on isosurface in the module library window. The isosurface should now appear in the viewer window. This can be rotated and zoomed in and out. I will now demonstrate how to change the properties of a module. When the properties of a module are changed, the image in the viewer window is automatically updated to correspond with these changes. Select the isosurface module in the network window, and its properties are displayed in the Properties window. The ISO value separates data less than and greater than a selected value. As this value changes, the image in the viewer window is updated accordingly. To change the ISO value, either click and move the slider to the left or to the right, or click on the number next to the slider and enter the exact value. I'm going to enter 60 in this ISO value row. You can change the color map by clicking on the example of the colors in the color map row and selecting the new color from the pull-down menu. I'm going to select Forest for my new color map. The opacity option determines the transparency of the surface, allowing you to see the layers underneath. To change the opacity, either enter a value by clicking and moving the slider to the left or to the right, or click on the number next to the slider and enter the value you wish to change it to. I'm going to change it to 0.25. Notice when you rotate the image you can see through to other specific layers underneath. A legend of what each color represents can be displayed by checking the checkbox next to Legend in the Properties window.